It is just a huge honor for me today to be podcast interviewing Dr. Emil Svoboda, PhD, DDS. He's lectured internationally about dental implantology. Today, he wants to talk about dragons, about the old dragons of dentistry. They have been frustrating the efforts of dentists for over 100 years. They are the root causes of treatment complications directly related to current prosthesis installation techniques. It is good to get to know these dragons and tame those dragons, because then they can, when they bite your patients might want to bite you, and that's not good for your health or your business. I used to love that when Carl Misch would say, you know, if the patient doesn't have enough money to do it correctly, then you should do it incorrectly, because then later when they sue you, you're going to pay to have it done perfectly. And wiser words never spoken. Dr. Svoboda, which means liberty, graduated from the University of Toronto with a PhD and a DDS, and has placed and restored thousands of dental implants over the last 30 years. He is an honored fellow of the American Academy of Implant Dentistry and a diplomat of the American Board of Implantology. He is currently working on an online dental CE course called Taming the Dragons. And I asked him to come on this show after reading, if you go to his website, reversemargin.com, he has several amazing articles. One of them is called Taming the Old Dragons of Dental Implant Prosthetics, which he just published June of 2019. So I was expecting an old dragon to come on this show today. And it looks like I'm the old dragon. But so where does this dragon come from? And you have pictures of T-Rex on there. Is T-Rex technically a dragon?
Well, that was the first thing my daughter chatted me up on. So, in fact, in my latest presentation, I actually imported some dragons. But T-Rex isn't a bad dragon because it's real. T-Rex was real, and so are these dragons.
Nice.
Yeah.
So basically, what are the three dragons?
Well, there are mainly two dragons, and those dragons they have names, and once we name them, then we can tame them. So the first dragon is called prosthesis dimensional error, or PD, and the second dragon is called the tissue effects, and it has two sons, which are called resistance to displacement and the gingival effects. And these dragons, they affect everything we do in the mouth. And the prosthesis dimensional error is the dragon that is involved with all the little errors that go into the making of a prosthesis, right from the impression to the model to the addition of implant analogs into that model to the manufacturing of the prosthesis to the polishing of that prosthesis. And Carl Misch actually spent a whole chapter talking about prosthesis dimensional error. He didn't quite call it that, and he didn't call it a dragon, but then, and basically between 1990 and 2000, the literature is full of prosthesis dimensional error. And then all of a sudden, the industry, the dentists, everybody just forgot this dragon, as if they already tamed it, but they didn't tame it, and it's still creating havoc to this day. Now, I've always been a cementer. That means I cement my prosthetics in. And I couldn't believe that in 7 years ago or 6 years ago that I actually was unable to control excess cement. And I know it's been prevalent. And some of the people who screw in their prosthetics, well, they think that they don't have to know about cementation, but you know, they're cementing crowns on natural teeth every day, aren't they? In fact, they're cementing on 10 times the amount of crowns on natural teeth than they are on implants. So I think everybody in our industry placing prosthetics should understand more about cementing. So listen up, all the screw-in guys. You have to listen up about getting better at cementation, because it causes problems too. So when I realized that I was not able to control cement, I kind of looked at the problem and I thought, well, I can't really dictate to the industry how to make their stuff more accurate. So I'm going to do something that I can do. And so I started focusing some research on intraoral cementation. And I looked through the literature and there was not one paper discussing gingiva. Now, how many of our patients have gingiva around their crowns? That's right, all of them. But yet there's not one article in there that discusses how gingiva interacts with the base of the crown and the cement coming out of that crown during the process of intraoral cementation. And that's where I started my research. And that's where I discovered something called the gingival effects. And the significance of that is when the crown is being pushed into place with a subgingival margin, the contour of the crown touches the gingiva first and starts to create an O-ring or a seal against the gingiva. Now, all the cement that's trapped in the crevice, plus the cement still coming out of the crown, is put under pressure. And of course, it will go along the path of least resistance. So it'll go down those long contacts between the gingiva and the retainer, and it'll come, some of it will come up. But that's why the cement goes in many places way beyond where we would have expected that to go. And that's the major reason why we can't control cement, is the gingival effects.
Well, can I? Sorry to interrupt, but I got a lot of kids listening to this, and you know, when they email me, howard@dentaltown.com, a quarter of them are still in dental school. But how could excess cement be bad when you go to the ADA.org and they ADA seal of approval for implant cement shows they just have one Premier implant cement. So obviously, Premier implant cement couldn't get the ADA approval if excess of it was bad. They might be thinking that. What do you?
Well, it's not a matter of the cement being good or bad, actually. I mean, cement has different purposes. I mean, one of the purposes of cement is to retain the prosthesis. The other purpose is to fill in all the voids between the prosthesis and the retainer to exclude bacteria. So a lot of cements can actually do that, including the one that you mentioned. But it does not belong in the soft tissues below the gingiva, because we know through research that it creates an environment that creates peri-implant disease, loss of bone, inflammation, mucositis, things like that. And so that starts the whole process of that complication. And the problem is that complication is very difficult to mediate with current processes. There is not one technique that really takes care of peri-implant disease once it's started. So really prevention is the key. And so learning how to redirect the cement out of the tissues with a special margin design that does that, an inflected margin, and learning how to use cement space safely, which will help you compensate for prosthesis dimensional error, will go a long way to helping you to prevent the residual subgingival cement.
Nice. I really loved that on your website where you talk about, I just want to read something from your website that I think is amazing. And by the way, what is your major website? You have a lot of websites. You have your dental office, Park Place Dental Center. And of course, you're Canadian, so they spelled center wrong. They spelled it CENTRE. Someone's got to go up to those Canadians. And then you got Reverse Margin. You got bonespreadingworkshop.com, and you got Gordon Dental Arts. Is most of your should my listeners mostly be going to which website?
Well, the Rozart Dental Arts has nothing to do with me, and I'm going to have to look that one up. But the
that's the
place to go.
That's the lab with Milan Jovanovic.
Well, I have to see what they're doing because really, I just don't know what they're doing. But reversemargin.com is the source to get access to my articles that you can download for free and assess. And that's the place to go to learn about the stuff. And I have the dragons with the Tyrannosaurus Rex on it. That's 150 slides, so it has all the references you need to follow up to make sure that my assumptions are true.
Yeah, and on that, you said, in this land of microbiology, one can fit 8,000 bacteria on the cross-section of a single hair and stuff 8 million of them in a millimeter of that hair. And when we wrap that hair around a molar, that hair around the molar can have 250 million bacteria. Small things in our visual world are very big in the bacterial world. We cannot trust tactile and direct vision to deal with microscopic problems. We must deal with them in the mind's eye. Thus, misfit joints 95 to 232 microns are a grand entrance into a huge caverns of the implant body. And those are, it's, so you were thinking that's prosthesis dimensional error. You said there were two main dragons, prosthesis dimensional error, PDE, and tissue effect. Those are the two main dragons, right?
Yes. And prosthesis dimensional error speaks to that 95 to 232 micron vertical defect, and that was done in a study at the University of Toronto on an all-on-4 type of prosthesis. And here we go, we're still doing all-on-4s, and we're completely ignoring that problem. But yet, our regulating bodies and our universities, they're all crying and telling us we should do a better job. But none of them are looking into this problem. And so how can we do a better job if in fact we're not even being taught about this microbiological problem? And now I feel fortunate that when I was doing my PhD, I was doing it with the electron microscope. I was looking at collagen phagocytosis by periodontal ligament cells. So I was right in there doing my research, working on things in nanometers, not in microns, but in nanometers. And then my undergrad was all microbiology, virology. So my brain looks at things, looks at problems in the microscopic dimension, in the micron dimension. And if we want to get better with our dental care, with our prosthetic installations, with our implant treatment, we now are at the time that we have to look at it from a microbiological point of view. No longer will our eyes and hands tell us we've done a great job. We have to work in the mind's eye with what we know about misfits, about the two dragons of dentistry. We have to know about prosthesis dimensional error, and we have to then use our intelligence to overcome or tame that dragon. And then we have to become aware of the tissue effects dragon, and we have to think about resistance to displacement, and we have to think about the gingival effects, and then we can come to a solution. And I've already come to a solution, and I presented it at reversemargin.com because I built a reverse margin installation system. But you can come up with your own. Once you understand the root causes of the problem, you can come up with ways of overcoming it. But if you can't even identify the two dragons of dentistry, you don't have a hope.
And tell them why this is a problem. What percent of well, let's just start with the obvious. What percent of implants are failing? How long does it take them to fail? What percent of it's PeriImplantitis? Why do implants fail?
Well, we can start with that problem, and quite often the literature talks about failure rate. But it's not the failure rate. The failure rate's not bad at 8% in 10 years. It's not so bad. However, it has a 45% peri-implant disease rate, which is 30% mucositis and 15% PeriImplantitis. And we don't have a handle on that. We can't control that. And the problem is about half of that problem is caused by us. It's caused by us by creating implant abutment misfits, and it's caused by us by leaving cement under the margins of our crowns in the tissue environment. And we don't even know why we're doing that. So this is why I have that metaphor about the dragons of dentistry, because once you get that in your mind, whenever you see a new system coming out, look at the dragons. Look at how they overcame the dragons. And if you can't see it, then just walk on by, because they haven't solved the problem because they're not even aware of it.
So that's amazing stat. I mean, you said implants failures, 4% at 5 years, 8% at 10 years. But, the big but, 45% of implants have peri-implant disease, and you said 30% is mucositis and 15% is peri-implantitis?
And Howard, I just want to tell you that Derek et al., that's a Swedish big research group, they came out with a figure of 65%, and this is per implant. And a lot of our patients have more than one implant. So pretty well, almost 100% of our patients are dealing with mucositis or peri-implantitis. And we in our installation processes have exposed them to risk factors unnecessarily.
Okay, so explain to the kids the difference between mucositis and peri-implantitis.
Well, mucositis is like gingivitis, that you have the gums all swollen up and they bleed easily, and there might even be a little bit of pus, but you don't see bone loss on your x-rays or when you do your periodontal probing. Peri-implantitis is like periodontitis, in that now we're seeing loss of visible bone, and we also have pus and bleeding and things of that nature. And with this high percentage of our patients going to have to suffer these things, now they have to undergo additional cleanings, they have to undergo flap surgery and many other things, and they have to pay for that, and they have to go through the suffering of dealing with it. And quite frankly, dentists have to often do it for free because the patients become very unhappy with having to deal with complications after they spent the money they spent to try to get themselves in order. So my feeling is that if we want to do our job properly, and I know we do, and I would say to the young dentists out there, at least, I've always put my patients first. And I've always tried to protect them from the things I could. And a few years ago, I didn't know the things I know now. Now I know I can optimize my implant abutment connections every time. It's not a guesswork. It's not a lottery whether I'm going to do it or not. And I know I can prevent residual subgingival cement. I can do it every time, not every once in a while. And so if I can control these two things, I can lower the peri-implant disease rate by about half, because I've extrapolated that number from Wilson's paper and many other people out there who have talked about peri-implant disease. So half of it's our fault, and we should clean that up. And I have a way of doing it, and I'm sure many more ways will be developed as time goes on.
Okay, so you're also saying that because of what we said about thinking microbiologically, that, we just can't comprehend how small these bacteria are, that cementation is better than screw-in. You'd rather be a cementer implant. If you're an implantologist, it'd be better to be a cementer than a screwer. That's what you're saying.
Today, knowing what I know, when I talk about myself being a cementer or a screwer, I am neither of those. I am neither of those two people that learned this in dental school, because all the techniques we learned in light of the new knowledge are not sensitive to the dragons of dentistry. They're not sensitive to prosthesis dimensional error. So let's just look at, for example, the screw-in technique. The screw-in technique assumes accuracy. It assumes accuracy. In fact, they have to use multi-unit abutments in order to make things even go in, because you can't use the regular abutments. You have to use multi-units, but they give a little bit of play. But the problem is they assume accuracy, and then they fall real short. And the problem is just the place of where the abutments are connected to the prosthesis. So for example, if you could put the abutments in first, now you've divided up the two dragons. You've separated them because together you can't defeat them. But if you separate them, now you have a chance. So for example, let's take the screw-in technique. Let's not let the laboratory attach the abutments to the prosthesis. Let's not do that. Let's get them to give us the abutments separate. Now we can put our abutments in and we don't have prosthesis dimensional error because we don't have prosthesis dimensions to deal with. So now we can put them in and we can optimize each one. Problem solved, right? We've optimized every time, and we can do it every time as long as we take care of the tissue effects. That means as long as we don't let tissues get in between us and sitting the abutment down. Now we can take the prosthesis and we can cement it into the mouth on top of the abutments, right? But you have a screw access hole that's been covered. So now once it's cemented, you could take the whole thing out, couldn't you? You could just take it out, clean it up, and re-screw it. And now for the first time ever, you've presented your patient with passive implant abutment connections. For the first time, you've solved the problem. It's so easy. But no, because of convenience, a lot of dentists just want the lab to put it all together. But as soon as you do that, what does the lab got to do as reference? They have a model, but the model is inaccurate. So when they assemble it on the model, the connectors on the abutments are constrained within the prosthesis. And now we try to put it in a mouth and it doesn't fit. And so we try to use the screw-in technique. Well, we got to put the middle screw in first and then this one and that one because we're trying to force it into place. But you know we can't force it into place. It either fits or it doesn't fit. And there is prosthesis dimensional error and the screw-in technique. That's the biggest failing. And you're doing all this at the same time. You're doing this all at the same time as you're trying to fight the tissues. And you know, you think, oh, well, if when I start screwing it down, I can squeeze the gums out of the place. But I can tell you, you probably can't. And I'll tell you why. Because gums can be very flexible close to the crest. I mean, close to the free gingiva. But as soon as it gets closer to the bone underneath or closer to the adjacent teeth, it becomes very hard and you can't predictably displace it with your installation. So when you're screwing this whole massive construction into the person's mouth, you're trying to squeeze the tissues out of the place. And at the same time, you're trying to adjust contacts if you have any. And at the same time, you just can't do it. And that's why you have 95 to 232 micron misfit, and you're putting your patient at great risk on a microbiological level. And there's no solution to it. Once you've done it, the patient's screwed. Because how do you fix an implant abutment misfit? How do you ever fix it? You can do all the surgery you want, you can't fix it. The only thing you can do is disfigure the patient to the point where the gingiva is below the connection. And then maybe the PeriImplantitis will settle down. So that's the problem. And Derricks et al., in a paper, I think it was 2016 or 17, they compared the amount of PeriImplantitis with these big frameworks with 4 or more retainers compared to 3 or less retainers. The 4 or more retainers had 15 times the amount of PeriImplantitis, 15 times. So it's a big problem. It's a big problem. Now, on an all-on-4 screw-in technique, for example, how many of your implants have to fail before you have to take the whole thing apart and start over? There's a joke going around saying all on 4, none on 3. And so it's a big problem. And now, in addition to everything else, you've chopped off 4 or 5 millimeters of bone off the ridges. Now you got a big problem on your hands. So anyway, now I'm getting distracted from the main thing. I just seen another case yesterday, and I cry. I look at the case and I see all that beautiful bone that they're chopping off, and I'm thinking, wow, this better work. And I ask myself, how many of these cases have to fail before you never want to do it again? Right?
Right.
I mean, I see a lot of techniques out there that I look at them and I think, how many of these will have to fail and I never want to do it again? Like, for example, some of these bone augmentation techniques where they chop a lot of, well, how about bone osteodistraction? Oh, that was very hot about 10 years ago.
What was it called? Bone what? Bone what?
Osteodistraction. That's where they severed the bone and they had a screw that would unscrew the bone and they could grow bone. And when I see that came up about 10 years ago, I thought to myself, wow, they're dancing around that mandibular nerve quite a bit. The lingual nerve is right there. And even they're dancing around that bone in the anterior maxilla. Like, how many of these blocks have to fail before you never want to do it again? And you know what? A lot of people never want to do it again anymore because now you don't hear it on the podium anymore. But 10 years ago, it was a hot topic, osteodistraction, and that's it. And so the same goes with these big cases that are so invasive that depend on everything to function. Well, you know what? It doesn't always function. And if you're building into it, now just look at this a little further, because now I'm starting to think it through. So you got an all-on-4 case. You got implant abutment misfits, guaranteed. It doesn't matter whether you did that altered cast technique or not. Guaranteed you got these fits because the studies were done with altered cast techniques. So you got this misfit joints. Now, why don't we cantilever forward so we can put lingual access, screw access, so we can cantilever forward and cantilever back, and let's put extra force on these misfit joints. Oh, well, not only that, let's make it impossible for dentists or their patients to clean under them. Let's make it impossible. Let's block all the access so we can't even monitor what's going on. You see, it's absolutely crazy the way that stuff is gone. Even with a single tooth screw in, the dentist's challenge is to line up the path of insertion with the screw axis, the screw channel of the implant. And the implants are never parallel to the path of insertion. So if you have any contacts with the crown of the prosthesis or the prosthesis, the crown if it's a single crown, it's a race between who's going to be able to be satisfied. Will the path of insertion, when the crown is locked in between two teeth, will that take precedence over the fit, or will the screw channel in the implant take precedence over fit? You see, that's challenging enough, and you're doing that while you're fighting the gingiva and the tissues adjacent to it. So that's challenging enough with a single tooth with 3 teeth. No wonder they got 15 times the peri-implant disease. No wonder. Okay, so we got to think this stuff through. With cemented stuff, yes, cement was a problem, but now we're starting to solve it. With cemented stuff, at least we put the abutment in first. We put it in first so we don't have the prosthesis dimensional error bugging us. We don't have contacts pushing us off the base of the implant, right? We put the abutment in first. We can optimize that connection as long as we do something with the gingiva that doesn't get in the way, right? So that at least we have a chance. So by separating the dragons, now the challenge is controlling cement. Okay, so let's not use downward facing margins. I mean, they were made 100 years ago when people, they just didn't understand that intraoral cementation was a hydraulic event. They didn't really get it. They just did the best they could with the technology they had. But now we know if you have a garden hose and you kind of adjust it, you can spray your garden hose forward, or you can make it a fan, or, it's a hydraulic event. So you control it by the shape of your nozzle. So if you have downward facing margins, where do you think the nozzle's pointing? It's pointing right into the tissues, and you got the gingival effects to help it along. You see? So if you invert you make an inflected margin, a reverse margin, well, now you can redirect the cement. But the abutment has to be even more intelligent than that. It's not enough just to redirect the cement. What you need to do is you need to get the gingiva out of the way. In hockey terms, you need to get it out of play. You need to not be fighting the gingiva when you're doing the cementation, because otherwise you'll get the gingival effects. So now, if the intelligently designed abutment pushes the gingiva out of the way, now the gingiva never sees the base of the crown. It never sees the base of the crown. And so now you can safely use cement space in order to compensate for prosthesis dimensional error, because that crown now can self-center and it can go onto the abutment. It have a little bit of play, and you can get it down. You can get it down in low pressure, not like 40 Newton centimeters like we do when we're trying to push the gingiva out of the way, and we're working in the back and we're trying to overcome contacts. So it makes it a lot calmer. Now I don't sweat like a dog when I'm cementing stuff in. It's so controlled. And dentistry is all about control. And so therefore, by just knowing what the dragons of dentistry are, it's led me to designs that are specifically put into place to overcome or mitigate or tame those dragons of dentistry. And I've done that, and the tissues look beautiful around the prosthetics when you use that technique.
But when I talk to dentists about implantology or implant failures or anything like this, this comes up. But your solution for yourself, for your own self, you said you could do it any way you want to do it, but yours is technically the reverse margin technique, correct?
Yes.
And that is that it is the reverse margin. Your diverse margin is a design feature that describes the shape of the margin built into a custom abutment and its complementary prosthesis. It affects the direction of flow of cement during the process of intraoral cementation. The reverse margin redirects the flow of cement away from rather than into the tissues that surround dental implants. This margin design can be used as part of the cement control system proposed by Emil to prevent or reduce the occurrence of peri-implant disease. This is what you're doing in Canada.
Yes, I've been doing this. So I got about 800 implants restored in this fashion already over the last 6 years.
Okay, so how does my listener right now, they're thinking right now, okay, I'm going to try this. The next case, I'm going to do Emil's reverse margin. What do they do? How do they do it?
They got to contact my lab, because I have a lab attached to my practice that I had a lab for over 25 years. I have a milling center in it. So our milling center can work with their laboratory to provide the reverse margin system for them. And
so they just go to that website. So they can find everything on reversemargin.com, or what's
yes. And then they should get their lab in contact with our lab, and we can become the milling company for their lab until we get them up and running. And then they can do it themselves. But not every milling machine can mill the reverse margin, because it needs at least a 5-axis. It needs the articulation to be able to do it. Because a lot of milling machines were made for downward facing margins, and they're not adaptable. But we've now located a number of machines that can do it.
By the way, and your name on the internet, half the time it's Emil Svoboda. The other half the time it has LA in the middle of it. L.A. What is that?
I got to be a little bit more specific, because there's a psychologist out there called Emil Svoboda that actually owns a website, and so that's not me. So LA works, but if you put Dr. Emil Svoboda dentist, then I'll come up as well.
But you just said something very important, and that is you're a dentist out there and you're listening to this because you want to learn implants, but you got to wear a lot of hats. And the internet is the biggest thing that happened in my lifetime. I didn't even see it coming when I walked out of dental school. And when I'm trying to contact dentists, I mean, they'll have on their website, their address will be ST. On Google, it'll be spelled out street. You have there's no such thing as artificial intelligence. It's just fast computers, machine learning, algorithm sorting, and you have to have an exactly constant internet profile, because when the internet comes up with two Emils and one has an LA in the middle of it and one doesn't, it does not know what to do. It can't think. It has no intelligence. And when you talk to these SEO people, they say most dentists should spend all their time just cleaning up all the basic mistakes before they should even consider doing anything fancy. So like Emil, that's a classic example. You have to make a decision, and you have to include LA because there's 8 billion people on the planet. So my gosh, some of those names on Dental Town, I mean, and they say, well, I don't like going by my middle name. I don't like my middle name. And I'm like, that's between you and your mom, okay? But for the internet, you got to have a middle name. So you have two middle names, L-A? So you have
it's Lubo Anton.
It's what?
Lubo Anton. I was born in a DP camp near Augsburg, Germany, after the Second World War.
What's a DP camp?
DP was displaced person. So right now we have a lot of displaced people roaming the world too, because the infrastructures have been blown up and they have nowhere to go. And I was one of those in 51. And that's where we were. We were in a DP camp. And when we came to Canada, we were referred to as a group as DPs, displaced people. And that's what it is. But now, of course, United States and Canada have a lot of us DPs that have become doctors, dentists, lawyers, railway workers. My brother worked his whole career on the Canadian National Railway, and we've been very productive in our society, and we work hard.
Yeah, I don't want to go from implants to politics, but the one thing that I cannot comprehend. Well, I comprehend it. The person most likely to shoot you in the foot is always going to be yourself. And if, the only thing that made the United States and Canada great was centuries and centuries of immigration. And if you talk to any economist, they want to open back up Ellis Island and just let people move. And whenever someone moves from another team to come play on your team mathematically can only get better because you have more players to choose from. And I'm so sorry that you were born in a displaced people's camp in Germany in 1951. And look at you now. You go, girl. You are crushing it. And Canada is so lucky to have you. So back to implantology. So if they want to do their first reverse margin abutment crown design, they're going to go to reversemargin.com, and the link to your lab, but they got to email. See, I'm afraid your email might not work, because if the Diamond Dental Studio.
Why don't they just email me, Dr. Svoboda at rogers.com. I know that works, and I'll clean the other stuff up, and I'll help them through it, because I want to help them through it. I think it'll make a big impact. You know, there's 17 million implants placed every year worldwide, 17 million. And we're still creating these issues. I want to try to make implant treatment better, and I want to make dental treatment better. It's been my purpose. And I want to help other dentists who make it their purpose.
Well, that's a hell of an amazing purpose. So walk them through their first case. So do they need to start with the planning? Do they need where do they need to start with this?
Well, I set up a system where I call it 1, 2, 3. Basically, when they place the implant, they should put a healing abutment on it that's wide enough to be able to accept the prosthesis or the abutment that they want to place. I think one of the big mistakes a lot of people made, including myself, is we put a healing abutment that's too small. And now we're faced with the tissue effects called resistance to displacement when we want to put the abutment in. And now we got to raise a flap in order to connect it. So when you place your implant, put an appropriately sized, wide healing abutment on it to make a hole that you can see the implant. And so when you take your impression, the lab knows where the gingiva is going to be. And so that's the first step. The second step is use the reverse margin abutment. It's been intelligently designed to mitigate residual cement problems and prosthesis dimensional error. It's been designed for that purpose. And it's now made out of, I do a zirconia hybrid. Zirconia is beautiful and the tissues love it. So we give the tissues a large bit of zirconia to attach to. It'll make hemidesmosomal attachments. It'll make a great barrier, a great shield against invasion from the dirty oral cavity. And now the crown goes on top of that. So now we cement the crown on safely so we don't put cement beyond the margins of the abutment. And you know what? It's accessible for cleaning by the patient, and it's accessible for cleaning by the hygienist. And you don't have to raise a flap if you need to clean it better. And it just makes life so much simpler. So give me an email, send me an email if you're interested, and let me help you through it. And I'll make sure you get what you need, because as I was doing my project, I realized there are so many different technologies, so many different parts, and sometimes it's difficult to do the handshake to integrate new things into your treatment plan.
And another thing, you're a prolific poster on Dental Town. You got 100 posts or more. I'm trying to think of, most people listening to this are townies. Is there a thread that we could put all these details on to? Would it be the thread safer cementation by avoiding the formation of cement voids? Would it be, is there any particular post that you think I should start like posting this podcast on?
I would say yes. Why don't we? Because I made up that metaphor of the dragons. Why don't we make a thread there, and I'll contribute stuff to that as soon as I can. And well, let's talk about safer prosthesis installation. Don't limit it to cement, but you know what? The whole cement versus screw debate has been nothing but a distraction for the last 30 years. It distracts dentists from looking at the true causes of problems and to actually be hopeful in trying to invent ways of overcoming these problems. It's just been nothing but a distraction. It's like a civil war between dentists. Oh, I screw. Oh, I glue. It's a stupid debate. The real debate should be, how can I make my patients safer? How can I optimize the connection of my parts? How can I prevent exposing my patients to risk factors that I can? You started a thread 3 years ago that's got 53 follow-ups, cement control with the reverse margin design. Do you want to keep adding to that 3-year accumulation of knowledge, or do you want to start a fresh post all from new? Let's start it fresh.
Okay, I'll do it right now. So back to your debate. Anyway, I don't want to switch gears completely, but yeah. I want you said that this talking about cementing or screwing for the last 10 years has been not as productive as good. Whenever I listen to dentists talk about implantology and they want to get into implantology, they think it's all about having the guts to go buy a bunch of equipment, a CBCT and a big training deal in Dominican Republic. And they're looking at this as a big financial decision. how should they be approaching this? They got, let's say they got out of dental school a year or two ago. They've been doing their basic fillings, crowns, cleanings, and they decided the two fastest growing areas in dentistry around the globe is clear aligners and implantology. They're the, Warren Buffett says, don't go into a business that where someone else sets your fee and is capital intensive. Well, insurance companies around the world are setting fees for cleanings, exams, and x-rays, and they're not setting fees for ortho and implantology. And so it's obviously the most robust section to go into. If you're a young kid and you got 20, 30, 40 years of flying, you can fly in a straight line with clear aligners and implantology. But they're thinking, if I go into implantology, I got to buy a bunch of expensive equipment. Is that true or false?
Well, I don't think they need a lot of things. I don't think they need a lot of things, but they do need an installation kit and they need to know a few basic things. I mean, you can't do implants unless you know how to do a little bit of grafting, because you're rarely going to find cases that aren't going to require a little bit of bone augmentation of some sort or other. And so one of the primary bone augmentation techniques, I think, that should be really basic to implant dentistry is called the bone spreading technique. And I did have a website on the bone spreading technique, and I really liked doing the workshops with that. However, I realized after that that most of the complication was coming from the prosthetics. So even though I love surgery more than prosthetics, I realized that I really had to focus my research on prosthetics, because what good is all the efforts the surgeons put in to do a beautifully integrated implant and replace that bone when the prosthetics screw things up? But let's get back to the question. So with a small bone spreading kit and a handpiece and a kit for pertaining to one implant company, you can do a lot of surgery. If you need a CT scan, then you can ship it out. There are a lot of services that will do it very economically. So if you need to look at it, but one of the CT scanners you have right in your own hand, the digital scanner, is called the fingers. And you can get a lot of information with your fingers. When you put your fingers in the mandible down, you can feel that little lingual concavity, so you know the angle of your implant. And other teeth, most of your implants are going to be single teeth. So if you know where the concavity is and you can place a drill between two implants, you don't need anything else. All the rest is just hype. And besides, you should be able to do that. You should be able to work with your assistant to dead center it. And if it goes off a little bit, it doesn't matter anyway. Okay, so you don't really need a complicated surgical kit. I see the direction, the implant companies, they want to sell parts. That's what they're in the business for. They're selling parts, and yes, you can buy them as you become more sophisticated, but you don't need them all right away. And always remember, their job is to sell parts. Your job is to deliver treatment to your patients. And so for that, if you had a little bone spreading case, say from BTI makes a beautiful little 4-unit, it doesn't cost a lot of money, BTI bone spreading kit, so useful. Then get a drilling kit, a drilling machine you can get from, Selvin. From Selvin, you can get a nice drilling machine from Selvin. And now when it comes to prosthetics, you don't have to buy a lot. I use an intraoral scanner. I use a Trio scanner. It's fairly expensive. It's $30,000, but you can take a physical impression. And scanners are just approaching. Scanners are just approaching in the mouth. They're just approaching the accuracy of a good physical analog impression. And we shouldn't forget that, because when you are talking to implant companies and scanning companies, they make it sound like their impressions are more accurate than a good intraoral impression with material. Then it's not true. It's absolutely not true. They don't have research to substantiate it. And when you look at research where they did it on a desktop, that doesn't mean how it looks when they do it in your mouth because they don't have tongues and saliva and blood in the mouth. They don't have a topography that they got to deal with in the mouth. None of these scanners do a lot better or even equivalent to a good intraoral impression. So then you don't have to buy the scanner right away. However, if you want to work with zirconia has to be milled. So you send your good impression to the lab will make a model, and then they'll scan that. So what happens here is you're actually increasing your error a little bit, okay? So if you assume that your model and your impression and your prosthesis is inaccurate, now you're assuming correctly. If your whole treatment depends on you assuming that it's accurate, then you're fooling yourself. So anyway, back to the new student, just take an analog impression, send it to your lab, let them digitize it. Now they can send it to me in my milling company, or they can send it to an authorized labs. I'm working with 2 labs in Chicago right now. If they come through, then you'll be able to order them from Chicago. But I'm willing to work with labs in California. I want the whole world to use the reverse margin system because it's better for patients. And we have to get off doing stuff that's 100 years old. We have to stop using downward facing margins. We have to stop pretending things are accurate and screwing things up and screwing our patients up. We cannot do that. We can't continue doing that.
Okay, so to hold your feet to the fire, she's asking specifically, what implant system do I, or pick one. If she had to buy one implant system to place, there's 700 implant companies.
I know.
Over half the world's implant companies are in Italy. Italy has 400.
Yes. Well, I've just started transitioning to a conical implant, and I'm using a very cost-effective, high-quality product called Spiraltech, and they're in Chicago. And I quite like their implant. I don't have years of experience with it yet, but I think that's a good start. If you wanted an external hex, then I was using BioHorizons before. I always had good results with that, but I think the conical connection might become a little bit more mechanically stable over time, and so I'm getting some experience with it. It has a few nuances, but we can talk about that in more detail on a course.
Okay, but you just threw a lot of words at her. Why do you like the conical system? What does that even mean to you?
The conical system, they often marry together with a platform switch, and some of the research is indicating that the bone around them is a little bit more stable. But I never believe just the research. I need to see it in my own stuff, and my old stuff with the conical connection is not old enough, but I feel compelled to make the transition now to the conical because I think it'll be better for my patients. So if you're starting out why don't you just start with the conical connection? And Spiraltech is very cost effective, and so I think it's probably a good way to start. If you're used to an internal hex, then BioHorizons has a good internal hex, and so does Zimmer. But I think, you see, I have a hard time, I have a hard time equating accuracy and quality of product with cost for that product. And I know some of the implant companies, and I'll just throw it out there, like Straumann, Noble Biocare, they claim that they have highly precision connecting parts. And you know what? That's important. That's really important. But, in order to get FDA approval, a lot of the other companies had to have really good precision parts too, okay? So that's the first step. But none of the companies out there, not one, can tell you how to put them together in an optimized fashion. Not one. Not Straumann, not Noble Biocare, not Any one of them out there. Nobody knows how. So they all tout how good their parts fit together, but then they also want to push screw-in technique. And you cannot put them together the way they did on a tabletop for FDA approval. You cannot put them together in the mouth that way. So I'm telling you that if you put your abutments in separate from your prostheses, you can optimize the fit of those parts at least. If you put them in with the screw-in technique with a single crown, it's a toss-up whether you're going to be able to do it or not. If there's contacts, probably you might have big problems doing it. If there's no contacts, probably yes, you can do it. If you do multiple units, like a 3-unit bridge or a all-on-4, there's no way on planet Earth, there's no way you're able to do it. And that's a shame, because it's our duty. Would you hire a plumber that couldn't put the fixtures together in your toilet without them leaking? I don't think so. So at least what we should be able to do as dentists is we should be able to put the pieces together as per factory instructions. And if we can't do it, then we got to change our systems. And that's the problem. I don't even think there's even a university out there, and I'm challenging a big group, that can teach their students how to optimize the implant abutment fit. There's not one. And that's a shame too. So I think universities, governments, and industry have to become a lot more proactive and look at new systems coming out. And they should be looking at my system that I developed, because I developed it to take care of these problems.
And so you're that's Spiral Tech. That's Reinhard Cole, the CEO of Spiral Tech Superior Dental Implants.
I think it's Jonathan Yahov. Spiral Tech Chicago Implants.
But does it have a parent company out of Germany?
No, but they have their the implants, I do believe, are made in Germany. But I did speak, but I know Jonathan Yahov is the big guy there. And I'll look it up here as well. Spiral Tech.
Jonathan, okay. So I see it. Jonathan Yahov, and he lives in Chicago?
That's correct. And they have, so their main distribution center is there, and they're international. And when I was in Chicago, they had a lot of people from Turkey. Turkey is just full of Spiral Tech. They're really doing it well. And they had over 100 dentists come from Turkey to Chicago to look at this implant. And I really like it.
Okay, so you're saying, back to equipment. So you said you like Spiral Tech, which is spiraltech.com, SPIRALTECH. And by the way, there's no commercials on my show. This is, I'm learning about this as he talks.
We're just sharing information.
Yeah, we're sharing information. And number two, back to the CBCT. On the one hand, you and I are old enough to know that, we've gone through Motorola flip phones, Nokia. No one wants an old iPhone that you basically want a new iPhone every 3, 4, 5 years. Do you really want to buy a $150,000 CBCT and have it forever? Because I'm confused, because when I go to the MD world, none of them have their own MRI or anything like that. They say, I need a picture of this. They just fill out a form, and usually it's in the same parking lot or the same neighborhood. And so do you think they should buy a CBCT? And then what?
Well, I'm an old dog, and I've already paid my dues. So I have Plan Mecca in my office, because I like having the CT right behind me when I'm working, so I can refer to it when I want to. I do freehand dentistry. I'm not really controlled using guides. I'm not charging my patient for all kinds of guides to place implants when I can place it between two teeth as easy as anything else. I mean, I have a lot of dexterity being a dentist on how to place things. So that I have my own CT scan, but whenever there's pathology or something I don't understand, then I send it to a local CT business, and they have a radiologist on staff, and they will look at the pathology. So that's the way I've done it. But I don't think a CT is something that you need in your office. I think referring it out and having a CT taken is an excellent way to enter implant dentistry.
And we're very close to, there's several different AI teams that have made a lot of breakthroughs on reading these CBCTs.
Yes.
And it looks like that you were talking at the beginning, we started this program with how small the world is and how many bacteria can fit on something. Your monkey ape eye isn't going to see as good as machine learning algorithms going nearly the speed of light. So you might be not even want to have a CBCT because you might want them to go to a place, they'll take the CBCT, AI is going to read it, and you'll have everything you know instantly. Yeah,
but right now we still need a human interaction there, and it's still not that expensive. I think a CT scan in a difficult place, I think is important. I think to look at where the mandibular nerve is, a pan is sufficient. I think if you, in the mandible, if you use your finger to look for the lingual concavity, I think that's sufficient in the back. In the front, beware. There are some really difficult cases that are very skinny bone with concavities that will trick you. And so I think in the anterior, lower anterior, which used to be considered the safe zone, I think I would get a CT scan. If you're going to work around the sinus and you don't have enough bone underneath the sinus, then get a CBCT, whatever, and get that three-dimensional scan, because it'll help you. Because sometimes you can, with the bone spreading technique, you can pick up some bone on the buccal or lingual, and you don't have to do a lateral sinus graft or more complicated stuff. I've been doing that for years. Learn how to do bone spreading. It is basic to placing implants. Please, it's better than anything else. As soon as you get into particulate and other grafts, you're just going into another level of complexity that things can go wrong, and that at the end of the day, you're going to end up with a bunch of mush there rather than good bone. And in the courses, they always show you the good bone, but I can tell you sometimes, and too many times, there's no bone there at all. It's just a bunch of scar tissue with mush. So whenever you can use native bone, and that's what you use with a bone spreading technique, that's what you should use. It's more predictable.
So are you good friends with this Jonathan, Dr. Jonathan Y. Yahav in Chicago Smile Center Implantology? Is this a new leading edge guy?
Well, here it is, Howard. My whole idea with this reverse margin development was to make it available worldwide. And I'm on my own. And I've been trying to get Noble BioCare and Straumann and BioHorizons and many other companies interested in it, but they're interested in selling parts. That's it. And so I can't. And Jonathan Yohav, he's an engineer.
And a dentist.
At my system.
And a dentist.
And a dentist and an implantologist. And he looked at my system and he's seen it right away. He understood it right away. When I went to Core 3D in Calgary to the owners and I showed them my system, they got it right away. And I went to Las Vegas to make my pitch, and they turned around and said to me, why didn't we think of that? And so people in the laboratory industry, they get it right away. But there's so much bull in the dentist interactions with the industry, and their bullhorns are so loud that sometimes dentists, they feel insecure about making logical decisions. So what I say to the young ones, trust your eyes. Don't trust all the bull. Trust your logic. If it doesn't pass the logic test, then it doesn't pass the sniff test for me.
Nice.
And if it doesn't take care of taming those two dragons, learn about those dragons. It's a way. It's a grid for you to separate the chaff from the wheat. Okay, it's a very good filter. You know, sometimes the implant company reps and other dentists have said to me, "Why, Svoboda, you're like Chicken Little running around. The sky is falling. The sky is falling." No, the sky is not falling. The fog is lifting. After 30 years of implantology and doing my research, the fog has lifted. This whole idea of implant abutment misfit and overhangs and subgingival cement, we can prevent that today just by using our intelligence and just changing our systems a little bit. And we need to do that.
All right. Well, I started the thread on Dentaltown under Implantology. So Dentaltown is a message board. It has 50 forums. It's not like all the other social media from Facebook to Twitter where you just last in, first out, scroll back. So it's categorized. If you go to Jet Propulsion Laboratory or any scientific institution, they don't have LIFO, first in, first out, last in, first out. So one of the forums, Implantology, I just started the thread, Taming the Old Dragons of Dental Implant Prosthetics by yours truly, Dr. Emil Svoboda, PhD, DDS. His website's reversemargin.com. We'll continue the discussion on Dentaltown. You and Hogo are going to have an online CE course. I have one ready for him to go. So for you kids saving money, you come out of school $250,000 in debt. You shouldn't be flying across the country, staying in resorts, dropping $1,000 on a weekend to learn 3 things. So use your head. Read textbooks, read online CE. The easiest dollar earned is $1 in expenses saved. Learn how to save some money. Emil, thank you so much for coming on the show today. I learned so much. It was so exciting to podcast you. I hope the rest of your day is fantastic.
Thank you very much, Howard. Nice to speak to you.